In this video, we're going to take a look at how you can utilize your skills and experience in Substance Designer to take advantage of InstaMAT's powerful workflows and feature set. First, I'd like to show you what it's like to use InstaMAT and tap into some of the potential it gives you to create materials and texture objects. There are many ways to use InstaMAT. It can encompass your entire asset creation pipeline or integrate smoothly into your production's already established ways of working. Let's first take a look at something you're probably familiar with. All right, so here we are in InstaMAT, and right now we're looking at the node-based graph UI, which we call the canvas. And so this element graph is generating this PBR wood texture material. And as you can see, if I zoom in, we notice that we have a lot of familiar nodes. For instance, we have some linear gradients, directional warps, blurs, slope blur. We also have some noises and some grunges like clouds. We're just warping things together, and then we're going to blend everything together using a traditional foreground, background blend node with a possible mask input. All very familiar. And so a lot of the nodes that you're familiar with have been expanded upon to improve their functionality. For example, if I scroll up here, we can see that we have the histogram select node. So if I Alt Option, click on this to make a copy, and go ahead and click on the output to view what's going on in my image viewer. And I can, of course, change the position and range and gamma. But you can also notice that we have this output levels widget here as well. So we can quickly change this to our liking. It's all built in right here. Now, if I zoom out here and I scroll down, we can see that we also have our gradient map node. So what I can do is I can option click another copy of this gradient map, and I can view the output, and this is now applying these color keys to this grayscale image input. And so what I'd like to do now is I'd like to go into my assets. We can see that we have this albedo scan here that I can populate in my image viewer. And now InstaMAT's UI allows you to dynamically change it based on what you'd like to do at the time. So what I can do is I can click on this arrow here to flip everything, and I can bring my image viewer and 3D viewer on screen at the same time on the left side. I can go ahead and drag this over a little bit. And so I'm just going to convert this to a dynamic gradient map, and this is going to allow me to capture more keys and have more control. And then I'm going to go to the eyedropper here, and I'm then going to drag a selection of keys from my image. And so now we can see those keys have been populated, and we have our converted gradient map here, remapping that grayscale image input. So InstaMAT also has some conversion nodes. For example, we have our height to normal conversion, where we can generate our normal information from a height map. We also have our height to ambient occlusion node as well to generate some really high quality ambient occlusion, again, from our height information. All the things that you do in Substance Designer on a daily basis. Okay, so what I've done now is I've expanded upon this wood material to add a few more components to it. In this case, I've added some planks and knots. And so I've done this so I can show off a few more features. For example, we have our flood fill nodes. So you know that in Substance Designer, you can use flood fill to identify separate pieces from a binary mask with different shapes. And we're doing that to identify the separate pieces in this knot creation process to apply different gradients to each piece. We're also taking advantage of the different scatter nodes here as well. So you can see on the left here, I'm using a circular scatter here to scatter some small shapes in that circular pattern. Also up here, you can see I'm using a tile scatter to generate the different wood planks. Now, what's really cool here is that our scatter nodes can also generate flood fill information right from within the node itself. So I can then take another flood fill to gradient here and apply a different gradient to each of those different planks. So if I take a look at my material, and maybe I can hit 3 on my keyboard to bring up my viewport settings and bring up the displacement factor, we can see that each of these tiles have a different slope to them. And so there are a lot of different scatter nodes that you can use, including, we can see down here, the guided scatter, which allows you to bring in many different inputs, whether it's a mask input, color input, offset input. And you can see I'm using a Perlin noise to drive the scale here so that I can distribute my knots in a very organic fashion. And so how do I find all these nodes? Well, one way to do it is by using the graph library. We can find that in the top left corner here, or I can press the 1 key. And so here you go, we can see that all of our nodes are organized into categories. Maybe I can go down into effects here, and I can find all of our flood fill nodes. And I can scroll down here quickly just to see the different kind of flood fill effects that we have, including a really cool one, which is flood fill to corner, which allows you to quickly create different rocks and pebbles. It's really cool. And so InstaMAT has an extremely vast node library here. So I can go to, for instance, my grunges. We have really high quality, awesome grunges that we could use here. We also have many different kinds of noises as well. I can click on classic here. We can find the classic Perlin noise, some fractal sum noises. They're really, really useful. And so what I can do, for example, if I'd like to bring this node into the canvas, I can just left click and drag it right in. However, there's a much better way to add nodes into the canvas, and that's by using something called Quick Search. So there are many ways to bring up Quick Search. One way is I can hit spacebar, and I can type in something like Perlin, and we have our Perlin noise. I can hit enter, and there it goes right into the canvas. Another way to bring up Quick Search is to right click in the canvas. Again, I can type in something like spots, and we can go and select through our different spots here, and I can bring one in. However, the best way to use Quick Search is by dragging out a connection from another node. So for instance, if we look at my material here, we can see that we have our outputs here, but we're missing a normal output. So maybe if I want to create a normal output here, all I need to do is left click and drag a connection out here and type in normal. And right at the top, you can see expose normal as graph output. So I can double click on that. And now we have our normal output. And so InstaMAT is smart. When you create an output with key terms like normal, ambient occlusion, base color, it's automatically going to hook up that output to the 3D viewport so you can see what's going on. And so if I'd like to take a closer look at that normal map, I can go over to my viewport and I can hit the C key. And this allows me to cycle through my channels. And I can go ahead, find that normal output and take a closer look right on my mesh. And so the user experience has been top priority here in InstaMAT from the beginning. And one good example of this is that when working in the canvas, you can dynamically switch between grayscale and color information right within the same node. So for example, if I go to this tile scatter, we can see it's exporting some flood fill information. I'm going to drag out a connection again to use Quick Search, and I'm going to type in random color. And so you can see with the context sensitivity of Quick Search, it knows that I'm working with flood fill information and that I want to assign a random color from this. So I can go ahead and hit enter. We have our flood fill to random color. However, sometimes what I like to do is I like to apply random grayscale values instead of color information. So all I have to do is go to the top here and switch to grayscale. I don't have to deal with multiple nodes dealing with different kinds of information. And InstaMAT makes it really easy to interact with different types of permutations. So for example, if I go ahead and bring in a blend node here, and maybe I'm just going to bring in a Perlin noise, and you can see that the blend node has automatically switched to working with grayscale information. Now, if I change this flood fill to random color back to color information, and you can see that's denoted by the green dot here versus the gray dot. If I drag a connection and connect to the blend, InstaMAT's automatically going to assign a conversion node in between the two. So it's really easy to work in between these different permutations. Now, here's another feature that I really like. If you go to the bottom right corner of the canvas, you can see that we have the mini map. And so I can drag this square here to easily navigate around the canvas and find all the different parts of my graph. And if I zoom out here, you can also see that the frames, or what we call comments in InstaMAT, also have these colors that show up in the minimap as well. And also you can see that these comments have numbers next to them. And that's because we can assign a shortcut hotkey to all of our comments. And so I can press the Alt or Option key, and for instance, this one's 2, so I can frame up that comment here. I can go to 1 down here to work on my knots. Maybe I want to go to 4, and I can adjust this conditional select. And in addition to that, we can also drag selections over the minimap to frame up that portion of our graph as well. So there are many different ways that you can quickly navigate the canvas here, and that's really important as your graphs start to grow. Now, as I've mentioned, this element graph is creating a PBR material, and we're generating our regular PBR maps, such as you can see the base color, normal, roughness, etc. Now, you could export these maps as image files, or you could use the .imp InstaMAT package, or as we like to say, .imp file with one of our integrated plugins for pieces of software such as Maya, Blender, 3ds Max, or even Unreal Engine 5. And this gives you the procedural functionality that you would expect, such as being able to tweak published parameters or change the graph resolution on the fly. Speaking of parameters, let's take a look at how we can set some up here for our material. So let's say that I'd like to be able to control how many planks of wood we have here in our material. So what I can do is I can go to this tile scatter that's controlling how many planks we have, and I can expand it here, and we can see all the parameters that we have available to us at the moment. And right here, the one that I want to control is the count parameter. So I can change the Y amount here, and we can choose how many planks we have. So all I need to do to be able to expose this parameter is drag a connection from this count pin into the canvas to invoke a quick search. You can see that we can expose the count as either a public graph input or a private local variable. So if I choose a graph input, I'll be able to control this from the outside, but if I like to keep this information private right within the graph, I can choose a local variable. In this case, I'm going to do a graph input, and I'm going to give it a name. So I'm going to call it plank count. And I'm going to hit enter. And there we go. You can see we have our parameter in the canvas. And if I click on the graph, we can see that we have our plank count here. And I can now adjust the plank count accordingly. And so if I'd like to see how this tiles, I can always go into my viewport here and hit the U key or this 1 or 2 here. And I can dynamically tile the material to see what it looks like. And I think it's looking pretty good. And so this highlights one of InstaMAT's most powerful features, which is the ability to write arithmetic or expressions right in the canvas alongside your material and image-based nodes. So not only do we see that we have our variables here in the canvas, but if I go to the graph library again, go all the way up to the top, we can see that we have our element expressions here, and we have all kinds of arithmetic and expression writing nodes here, including like math nodes. We have random number generation for different variable types, all of that right here. And so a good example of using this is the lerp node. So if I press F to frame everything up in the canvas, I can get a nice overview of everything that's going on. What I'd like to do is zoom in to this section here at the top. And what I'd like to be able to do is easily add some grunge to my material. So I've got this blend hooked up here, and if I increase the opacity, we can see that I can add some grimy spots to these planks. Now we can see that this opacity slider is pretty sensitive. If I go all the way up to 50 or higher, it's really intense. And so if I go all the way down to about 10%, I'd say that's looking pretty good. And so what I can do with the lerp node is I can linearly interpolate between two preset values, but still make it look like I'm going from 0 to 100%. So what I'm going to do is I'm going to expand the inputs of this blend, and I'm going to expose the graph input for opacity. And I'm going to call this grunge opacity and expose it as a graph input. So I'm going to zoom out here. I'm going to quickly make some room. What I'm going to do is hold Command or Control and use the right arrow key to just move all these nodes over. So now if I go ahead and right click to bring up quick search and type in lerp, we have the lerp float node. And I'm going to use the grunge opacity as the X input. And then my A and B here are the two values that I'm going to linearly interpolate between. So what do I want to do here? Well, if I go to my grunge opacity, I can see that really I don't want to go anywhere above about 15% or 0.15 for the float. So what I can do is I can go to my lerp float and I can say, well, A is the lowest value, B is the highest value, which is 0.15. So now if I connect this lerp float to the opacity, I can now go to my graph level, and you can see if I go to 0 to 100%, we're no longer exceeding that 15% mark, but we are interpolating between those two values. Now let's take a look at another example where writing expressions in the canvas can be really helpful. So what I'd like to show you is the conditional select node. Now a conditional select node allows you to choose which input passes through based on a condition here. So for instance, the condition that I'm using right now is that this planks and knots Boolean switch is true. And this allows me to turn on and off my planks and knots. And so this is great because it allows me to turn off particular parts of my graph, and when they're turned off, they don't process. So I can optimize my graph further based on the different components that I'm using at the time. So another way to illustrate this, if I turn off my planks and knots, what I can do is zoom out here, and I can click on this toolbar button here that says Render Unconnected Nodes. So if I click that, You can see that a good portion of my graph no longer has previews. In fact, the entire knots section here doesn't have any previews. None of these are being processed. And so if I go ahead and turn on the planks and knots again, you can see that those nodes are processing and we now get our previews again. So now that we can write expressions and math in the canvas, we don't have to dive into separate parts of the UI, different graph locations. It's all right here in the canvas, and it can keep me in my creative flow. So now that I have my material just the way I'd like it, I'd like to export these outputs here that I have on the right as image maps. And I can do that with our export dialog. And we can find that dialog with this curved arrow here at the top in the center of our toolbar. So if I click on that, you can see we have our export dialog. And InstaMAT has a very powerful and robust export system. And what I want to bring attention to is the template system that we have. So you can see if I click here, we have some built-in templates. You can see I can click on Unreal Engine here, for example, and we have everything we need. And I can go ahead and say export. However, the power truly lies in the ability to create and customize your own templates. So I'm going to go and create one here. I'm going to hit the plus button and call this my export template and hit OK. So each row here is a separate map that we're going to export. And what we can do is take the different information that we have here from our graph and assign them to different channels of the same image. And this is called channel packing. So I'm going to take the roughness and put it in the red, the metalness in the green, height in the blue, and I'll put the ambient occlusion in the alpha channel. Then I can rename this map, call it rough, metal, height, AO. Now, in addition to having all the information from our graph here, we also have really useful converters over here on the right. And so what I could do is I could drag this roughness to glossiness converter here onto this map. You can see it automatically renames it. I'm going to go ahead and add another custom output here. And we can do other conversions such as normal to DirectX. We can also do a PBR to specular color conversion right here as well. So right now I'm just going to supply the normal to DirectX here and say map as RGB. So now that I have all of my exported maps ready to go and set up, all I need to do is set up the output path here, the naming format. I can choose the type of image format that I'd like to export these as, and I can also set up the execution resolution for this material here as well. And then when I'm ready to go, all I need to do is hit export. So we've taken a look at different ways that you can add nodes into the canvas, either using the graph library or with quick search. We've also looked at how you can create graph inputs and outputs, whether it's a private local variable or a public graph input that's published that you can use in different pieces of software using our integrated plugins. We've also taken a look at how you can use expressions in the canvas, whether it's using a lerp node or using a conditional select to optimize your graph. Now let's take a look at how we can apply this material to a piece of geometry. So you can see I've applied a variation of our wood material to this door here. And so to take a closer look at it, what we're going to do is adjust the UI of InstaMAT again so it better suits our needs. And so what we're going to do is make it so that the viewport is taking up the center portion of our interface. And so we can do that by going to these top three buttons here at the top of our toolbar. And so what I'm going to do, if I go ahead and click on this cube here in the center, now the 3D viewport has taken center stage here and the canvas has replaced it in the bottom right corner. And what I can also do is hide the panels on the left. Again, I can go and click on the buttons that correspond with each of these panels. In this case, we're looking at the package management panel, so I can click on that, or I can hit the 2 key to quickly do that with a hotkey. And so now we have even more space so that we can take a closer look at this asset. So what's awesome about this door is not only has it been procedurally textured in InstaMAT, but also the mesh has been created entirely in InstaMAT as well. InstaMAT comes with a suite of procedural mesh creation and manipulation nodes, allowing you to generate some geometry and texture it all within the same element graph. So to demonstrate this, I've utilized the conditional select node that we talked about earlier. I'm just going to disable the textures on this temporarily. And so I'm also going to press 3 on my keyboard here, and I'm going to bring up the wireframe overlay so that we can see what's going on a little better. And so just like we were publishing parameters when we were creating materials in an element graph, we can also publish parameters that we use to create geometry as well. And so procedural mesh creation is really taking advantage of how we can do mathematical expressions and arithmetic right in the canvas. So you can see I've published some parameters here for the different dimensions of my door. So I can increase or decrease the width of my door, and you can see it's processing very quickly. I can change the depth, and also the height if I'd like. It's all happening very fast. And so I can go ahead and turn on those textures again, and we have our textured asset. And so the same element graph can generate the textures and the geometry that those textures are being applied to. And then we can export our outputs. So you see that we have our regular PBR map outputs here on the right, but we also have a mesh output here as well. And then all these outputs could be exported together. And to take this further, all of this can be automated using something called InstaMAT pipeline, which is an intuitive command line based interface into InstaMAT. So for example, I could type in that I like a specific kind of door with a specific set of dimensions, maybe change what kind of wood is applied to it, how much wear and tear is applied to it as well. I can choose whether or not to have silver finishings or gold, and then set the texture resolution. That I can go ahead and hit enter. InstaMAT will compile everything together, create the maps, create the geometry, put it all together all in one place. And in addition to that, I could also generate a beautiful render using the mesh render node that goes with it so I can supply it for fast feedback and iteration. Now, let's take a closer look at this door. If we look closely, we can see that a lot of the dirt and grime is culminating in the crevices of the mesh, and that's because this texture is taking advantage of baked mesh maps. InstaMAT has extremely fast GPU bakers, but unlike Substance Designer or Painter, you don't need to manually run a bake operation every time your mesh changes. Instead, you can use the mesh bake node right in the canvas. So all I have to do is change my mesh. Maybe I'm going to make my door a little bit thinner. InstaMAT quickly bakes those mesh maps and applies it to my texture immediately. So you can take advantage of all the maps that you're used to using when texturing, including the curvature, ambient occlusion, world position, etc., to continue texturing your mesh, except this time, instead of baking it manually, we're automatically generating those maps using that mesh bake node. I'd also like to mention that InstaMAT is creating and unwrapping these UVs on the fly as well. And so if I'd like to, I can go back to that export dialog box. We can see that our mesh output has appeared, and the dialog box has adapted itself so that we can now choose what kind of format we'd like to export our mesh as. Now, why stop at a door when you can create an entire building this way as well? And so everything here has been created in InstaMAT the same way that the door has been created. So we have the procedural geometry to create the stairs, the windows, even the columns, even these plants down here as well. And so if I quickly turn off the textures here on this one, you can see that I've exposed all of my parameters just like I would a material. And so I can go ahead and, for instance, if we go in and look at these columns here, I can easily change the displacement of these columns. I can also change the base that these columns are standing on. You can see that they are adjusting accordingly. And I can even change how many stories there are. I can make this a shorter building or a taller one. And adjust the window width. So I can make these really thin or take up more of the floor space. And so let me go ahead and get those textures back. And so one of the things I wanted to draw your attention to here is how I textured this front wall of the building. Now, each of these floors are separate pieces stacked upon each other. And I wanted to create a seamless brick texture across the whole front wall. And so I could do that by taking advantage of InstaMAT's material mesh project node. And so this allows me to take a material and apply a triplanar projection upon this mesh. And so what I can do is I can go to that node and go, for instance, to the scale, and I can change the scale of these bricks here and make it any size I'd like to, just like I would in any normal triplanar projection. And so because this is a material, you can see I have my new brick wall material here that I can go up and find that primary color, and maybe instead of a light color, I want to do more of a dark shade, and so I can just bring that down here. You can see that's updating accordingly. Now, in addition to the brick wall being projected, we also have some dirt and grime being projected across these different meshes as well, and that's taking advantage of the mesh decal node. And so if I click on this here, you can see that a gizmo pops up in the 3D viewport. And so we have gizmos in the viewport while working with nodes in the canvas in InstaMAT. And so all I have to do is just change the position of my decal here. I can use the W, E, and R keys to switch gizmos. I can scale this here if I'd like. I can use E to rotate and adjust it, and it works just like you would in any familiar 3D package. And so with gizmos in the viewport while you're working in the canvas, it makes it really easy to switch back and forth between putting in values and getting artistically exactly what it is that you're looking for. But of course, why now stop at one building When you can create an entire street. And by utilizing different project types, like the NPass graph, for instance, which unlocks the power of iteration, not only when building your materials, but also in creating simulations, or in this case, entire city blocks. And what's really neat is that all of these buildings or streets can have randomized parameters that can also be controlled by your exposed graph inputs. And so, with all of these concepts combined, InstaMat can encompass an entire asset creation pipeline. So we talked about one way how InstaMat can encompass an entire asset creation pipeline, but I also mentioned that MAT can easily integrate into your pre-existing pipeline. Let's take a look at one of the many ways it does this. One way of approaching materials is to use sculpted assets, such as bricks, rocks, or wood planks, to then create rock walls or debris piles. Traditionally, this would have originally started in ZBrush, where you created a tileable height map, and then you would have used another application to extract all the curvature, ambient occlusion, and normal information, and then bring that into Substance Designer to finally texture it. The problem is that once you export that height map out of ZBrush, you lose a lot of your procedural functionality because you're stuck with that one arrangement of rocks or bricks. But with InstaMat, you can integrate your sculpted geometry right into the material graph and therefore gain a lot of procedural capabilities. Let's take a look at one way that we can do that. So here I've imported a bunch of sculpted rock assets, and now what I'd like to do is I'd like to create a rocky ground material that's tileable and also gives me an unlimited amount of variation. So now what I can do is I can drag my rock.fbx and place it right into the canvas, and it becomes a node. And so if I right click this and choose View Mesh, we can see our rock in our 3D viewport. And now if I press 3 here and I go to my wireframe overlay, and so we can see that this mesh is very, very dense. I think this was dynameshed in ZBrush. And while InstaMat can handle a lot of polygons and geometry, maybe we can help it out a little bit by optimizing our meshes right here in the canvas. And so we can do this because InstaMat includes technology from InstaLOD, which is another program by the creators of InstaMat. We can do this here with the Mesh Optimize node. So I'm just going to drag a connection off from my rock mesh, type in Optimize, and go ahead and hit enter. And right away, you can see that we've gone from 127,000 polygons and we've cut that in half to 63,000 polygons. If I click on that, you can see here our mesh has been optimized. And all I have to do is just drag down the slider here to choose the percentage of how I'm going to optimize this mesh. And it's happening extremely quickly now. I've gone to about 12%. We can see we've optimized this down to 15,000 polygons from 127,000. And so if I turn off the wireframe overlay, and I switch between these two meshes, you can see that the details remain even after we've done such a high optimization. And so you can use this process to generate a chain of LODs and even unwrap your meshes here as well. It just goes to show that you can use InstaMat to apply your familiar process of working with nodes when generating materials and expand your capabilities by creating, or in this case, optimizing meshes. So now if I'd like to, I can export this optimized geometry. I can just click on the output here to make sure I'm viewing it in my 3D viewport. And then all I need to do is click on the floppy disk icon here to export it as an FBX. So now I've gone ahead and optimized my rocks. Now what I want to do is scatter them on a plane. So you can see here I have this mesh shape generator. It's generating a simple plane here. And I also have this node here called mesh drop on topology. And so the mesh drop-on topology node is an example of what's called an NPass graph, which I briefly mentioned in the last section. And so let's quickly take a look at what an NPass graph is before we continue building our material. So here's a quick example of an NPass graph. In fact, you can find this by going to the graph library, going to the tutorials section, choosing NPass, and then double-clicking on the scatter tutorial. So what we're doing here is we're generating some random numbers, and then we're using those random numbers to rotate, scale, and translate this InstaMat logo. We're then using a blend operation and outputting that blend operation to a special function for the NPass graph called didExecuteAssignment. Now, every time this NPass graph performs a loop, it's going to run this didExecuteAssignment function. And so you can see we've taken the output of this blend and we've connected it to this buffer input. Now, this buffer input is a special NPass variable, which you can see we've dragged into the canvas here. And so what happens is every time this NPass graph runs through an iteration, it's doing a blend operation here with the newly transformed logo and applying a maximum blend to the buffer, everything that was in the buffer already. And therefore, you can see if I click here and I increase the scatter count, which is increasing the number of iterations, I can drag this and we're now scattering our logo. And so we're iterating through the graph every time using the information in that buffer and applying a blend operation to it. And so this is how we're going to be scattering our rock geometry on a plane using an NPass graph's iterative capabilities. So let's get back to setting up our mesh drop-on topology node. So I've set this so that I want to scatter 3 different meshes, and I need to give it the mesh that I'd like to scatter things onto. So I'm going to take that plane, plug it into the mesh input, and then for the 3 scatter meshes, I'm going to input these optimized rocks. So now when I click on the output of my mesh drop-on topology node, we can see that we've now organically scattered these rocks onto this plane. And so now what I want to do is I want to generate a height map. And so like before with the prior example with the door, we can use the mesh bake node to generate all the maps that we need. So I'm just going to zoom out here. I'm going to right click to bring up quick search and I'm going to type in mesh bake. There we go, we have our baker. And so now if I click on the mesh bake node, we can see all the different baking outputs that we can generate. And in this case, I'm just going to test it out by baking a displacement map for our height. So I need a source mesh and a target mesh. And so my source is going to be these scattered rocks. And so for my target, I'm going to use that plane. However, what I'm going to do is slightly transform that mesh in 3D space and just bring it upwards a little bit so that I can bake that detail onto the plane. So I'm going to connect that transformed plane to the target. And now don't blink because the mesh bake node is already done creating our mesh displacement. I can click on that output here. We can now see our height map. So now I'd like to preview what my height map is doing. So what I'm going to do is I'm going to go to my viewport here and I'm going to hit V to pick a mesh, and InstaMAT comes with a nice high resolution plane here. So I'm going to double click that. We have a nice plane. And so I've set up some outputs here that pipe automatically into my base color, normal, ambient occlusion, and height. And so I'm just going to connect that mesh displacement into this reroute node here. You can see what we've got now. I'm just going to go to my viewport settings and I'm going to bring up my displacement factor a little bit. And we can see we now have a height map. Now, the only problem is that it's not tiling. InstaMAT has many nodes and tools that you can use to make images seamless. In fact, we have an entire video dedicated to the topic on our YouTube channel. So if you're interested in learning more, I recommend you check that out. And so I've gone ahead and made a little bit of room here. And so what I'm going to do is right click this connection, type in make seamless. And now I'm just going to hit enter to bring in that node. And right away, you can see that our height map is looking pretty seamless already, but I can dial this in even further. I'm just going to go to the softness here, bring that down, and maybe change the mask size just a little bit. And there we go. We now have a fully tileable height map being created by our scattered sculpted rock geometry. So now all I have to do is go back to my mesh bake node and I can continue to bake more information such as the ambient occlusion, the curvature, and the thickness, and utilize those just like I normally would to create my material. Okay, so now I've gone ahead and I've created my material here and I've utilized all those mesh maps. I've identified different rock pieces, used the curvature, created my normal, roughness, ambient occlusion maps, everything that I need to create my material. And what's really cool now is I can take advantage of the fact that we're using geometry right in the canvas. So again, I can go back to my mesh drop-on topology node way back at the beginning and I can go ahead and change the rotation. You can see that InstaMAT is now going to update that geometry, which is something we couldn't do with a static height map from before. And so in addition to that, I can also go to the random seed, either for the entire material or just for this scatter node, and get a completely different scatter of rocks, but still maintain that consistency of the material that I had before. Now, in addition to being able to adjust the geometry that we've already imported here, like I showed you, we can rotate those rocks. I wanted to show you just how easy it is to replace and add different geometry as well. So you can see what I've done here is I've exposed these mesh inputs as graph inputs here. So now I have mesh 1, mesh 2, and mesh 3. You can also see that I've brought in some bricks here as well into the package. And so all I need to do to replace my rocks is double click on this node here. I can filter this by typing in bricks, and I have brick 1 here. I can go ahead and do the same thing here with brick 2. I can see it's up at the top. And I have brick 3 as well. And there you go. You can see how quickly it's already baked those mesh maps, and now we have bricks. And so what's really cool about this is that if you use our integrated plugins with this element, say for example, we bring this into Unreal Engine or Unity, you can supply the geometry straight from Unity and easily scatter and build your material this way. You don't need to come into InstaMAT to re-export or recreate the graph. And in addition to using geometry from the outside, you can also utilize procedurally made geometry as well. So you can see I have this fun node here called the Awesome Shape Generator. And what we're doing is we're generating a mesh from this cute little smiley face. And so if I go ahead and replace one of my bricks with that mesh here, you can see that now we have these fun little rock textured smiley emojis scattered about. So it's really endless the possibilities that you can achieve just by scattering 3D geometry to create tileable materials this way. So now that we've seen a couple of ways of how to create materials in InstaMAT, either by creating shapes with compositing techniques or using 3D geometry to generate our height maps, let's take a look at how we can easily combine multiple materials together. Some examples of how this material workflow is useful is that you can build even more complex variations of your materials or build up a vast library that remains in scope of your project's design language. Let's take a look at how we can enhance our scattered rock material even further. Okay, so I have two materials here in the canvas. I have this forest path material, which looks really nice, luscious and green. And we also have the rocky ground material that we just created. And so what I'd like to do is I'd like to merge these two materials together in a nice organic fashion. And so we can do that with the material blend height node. So now that we're dealing with multiple materials in one graph, there tends to be a lot more connections that we have to connect back and forth, and that can become pretty tedious. So what we can do is we can use link category mode here, which we can find in the toolbar at the top. And you can see that all of the related outputs have combined together into one material output pin. And so all I have to do is just connect one material to the material slot here in the material blend height, and I can connect the other material to the second slot. And so now what I'm going to do is right click on the material blend height and preview that as a 3D material so we can see what's going on in our 3D view. And so what I can do is I can click on my material blend height and I can adjust that top offset, and we can see that we're blending that material together. And I'm going to adjust the opacity here to make it so that those height levels blend a bit better. And if we want to see what we're doing better, in addition to being able to use the top three buttons here to cycle what's in the center view, we can also use the Alt or Option key and the letter C, and I can now switch to my viewport in the center area quickly, just like that. So we can see we're getting some grassy patches in our rocky material, but it's not looking as cohesive and integrated as I'd like. So what I can do is I can use color matching in the material blend height node. So I'm going to say I want my material 2, which is this rocky ground, to match the color of the material 1, which is the forest path. So if I go ahead and do that, immediately you can see that our material looks a lot more cohesive and blended together. And I can adjust the opacity here so that we can dial this in a little bit more. And it's looking a lot more cohesive and blended together. And it was really easy to be able to do that with color matching. And again, I can continue to adjust the offset to add more or less grass. It's really easy. So if I'd like to take a more analytical approach to how these materials are blending together, I can use the image viewer. And so what I'm going to do is I'm going to press Alt or Option C to cycle back to the canvas. And we can access the image viewer by clicking on this picture icon here. It's right next to the 3D viewport. And so what I can do is I can open up multiple images in tabs. So for example, what I'd like to do is I'd like to compare this base color that I'm looking at here of my blended material with the original rocky ground. And so all I need to do is right click on my material, choose View Image in New Tab, and I'm going to choose the base color. So all I need to do is switch between these two tabs, and I can zoom in here and take a closer look, and I can do some A/B testing. Now, InstaMAT has a bunch of material effect nodes, which allow you to apply really natural looking effects to a fully made material very easily. And so we can find these by going to the graph library. Again, that's in the top left here, or you can also press the 1 key. And if we go to the material category and then the effects tab, we can see some of our effects here. And one of them, which is really fun, is the material effect water node. So I've gone ahead and I've dragged that in. I'm going to press 1 to hide the graph library. And so what I'm going to do is I'm going to connect using link category mode again, the material output here into the material input of that effect node. And we can see that we've now flooded our combined material. And again, I'm going to press Alt or Option C to cycle to the center here. And what I'm going to do now is go to the material effect water node and I can adjust the water level here. And so now we can see that I have more of this marshy, wet environment. And we can take advantage of some of these parameters. For example, we have the raindrops here. I can bring up the density and we can add some rain to our material very easily. And these raindrops are conforming to the curvature of the underlying material, which is really cool. And I can adjust the opacity here and really adapt this effect to what I'd like for my end result. And so it's really easy to combine multiple materials together, use link category mode, use these material effects to create more complex materials. We've covered quite a bit in this video, but there's so much more to discover. For instance, InstaMAT has a powerful photo materialization project type, making it easy to not only create materials from photos, but also generate unlimited variations of that material with its image synthesis capabilities. And another way of working in InstaMAT is with the layering project, which is a completely different experience from working in the canvas. With layering, you can set aside the technical aspects of working with nodes and connections and just focus on texturing your asset. And what's more is that just like working in the canvas, layering projects are scalable and can texture entire classes of assets as well. There's a lot to explore and take advantage of here. And if you'd like to learn more about a specific topic or feature, check out our YouTube channel. Here we have a continuous flow of content diving deeper into the topics you've seen today, as well as many other video series ranging from Swift sessions to focusing on specific nodes and features. Well, that's it for now. Thanks for watching, and we'll see you in the next video. If you enjoyed this video, drop us a comment below and don't forget to subscribe. For the latest news about InstaMAT, please visit our website and follow us on Twitter. You can find all the links in the video description below. Thanks for tuning in, and we'll see you in the next one.